good afternoon, good morning, good evening. Very warm welcome to the first Taxonomy Bootcamp London event of 2024. Delighted to welcome everybody. My name's Helen Lapel. I'm the Programme Chair of Taxonomy Bootcamp London. We run these events 3 times a year to bring together the taxonomy community from all over the world. We pull together the most interesting, thought-provoking people. And we have 4 brilliant speakers for you today. We've got 13 countries represented in the attendees, which is fantastic, from all over the world. I won't keep you for too long, just a couple of messages. So thank you very much, as ever, to our diamond sponsors, Synaptica. You'll be hearing from them in a sec. And new this year, our platinum sponsors, Quark, and you'll be hearing from them a bit later. Thank you to our partners from the wider community, so ISCO, Netix, SLA Taxonomy Division, CILIP Knowledge and Information Management. You can find a lot more about them on the website under resources. Please do go and look at what they do. I can't speak too highly of these groups. 1st of May, look out for our basics event, which is a deep dive for beginners to taxonomies, or it's a refresher and a chance to get your burning questions answered about how to build taxonomies. I always learn something, and I've been doing this for years, so I think it's a fantastic session. Recordings and slides will be available in a few days for everybody. Please use the chat to make comments, observations, but if you have questions, there is a specific Q&A function on the bottom of the Zoom webinar screen, so it's slightly different from maybe normal Zoom meetings. Please use that for your questions that we can put back to the speakers, because it's a lot easier for us to see and to track and to record. We'll probably remind you of that a couple more times because it's really helpful. Without further ado, I would like to hand over to Dave Clark from Synaptica to introduce both Synaptica and our very first session.
Thanks very much, Helen. And yeah, I'm just going to talk for a few minutes and have the pleasure of introducing our first speaker. So in those few minutes, I thought what I'd do is just talk about some of the really big challenges that we as a taxonomy software company have faced over the years. And they reflect, I think, what sort of the lots of people in different industries are dealing with. And this is complexity, scale, explainability, and trust. So if we look at the challenge of complexity, the world has changed radically. I've been doing this actually 30 years. And in that 30 years, just the change in terms of complexity of what we're all dealing with in taxonomy and ontology is huge. I've built this little sort of stair step to illustrate some of the high-level challenges and how the community as a whole has responded to those. And part of this has been the big shift from term-based taxonomy to concept-based taxonomy, and everything sort of moving to URI-based identifiers. This has had a huge impact in simplifying multilingual, but many other benefits as well. The taxonomy to ontology was the next really big step, and that has had many benefits, including the ability to do machine inferencing or generate knowledge out of existing knowledge. We used to have just labels as strings, and then labels became things. I know it's a little thing, but it basically means you can have metadata and relationships to the different versions of a label for a concept. It's massive increase in complexity and many benefits. Then came relationships as things, so the ability to add metadata to the join between two things, and knowledge graphs. So these were huge sort of stair steps in complexity, and really enriched what we're able to do as taxonomists and ontologists. The next challenge is challenge of scale. So very often we work with clients who have, say, 10,000 concepts. That's the faint line on this slide on the left. We've been working with clients with 10 million concepts in a single taxonomy. This is a huge scale challenge. And some of the ways that we needed to adapt to that is, we call it adaptive navigation, but basically, supposing you're clicking through a hierarchy and it's 10 more things and 10 more things, and then you click on something that literally has a million narrower things. This is a real life situation that we encountered last year. We have to adapt to that, and we adapt to that by trapping those kinds of scale incidents and then diverting from, let's say, a browse experience to a search inside experience. People still expect, of course, near sub-second responses. We can get very close to that, but the scale of data is definitely a challenge. Challenge of explainability, we really hit this in auto-categorization. And one of the things in a lot of auto-categorization is like the black box. How did it make the decision to categorize this way? And so the challenge there is really about making results very explainable, giving transparent rules that the taxonomist can interact with, see, and can quickly kind of rapidly iterate through those to change the results of tagging in a very, very transparent way. The last challenge is the challenge of trust, and this is actually probably a good segue to Fran Alexander. So generative AI absolutely stole the show last year and took over kind of a lot of our mind space, and for good cause. It really has incredibly good and powerful benefits for what we do as taxonomists and ontologists. But it has issues, and these issues are to do with privacy, the opaqueness of sources, the veracity of the results, and how we can basically build trust out of this. I won't go any further because I'm really looking forward to what Fran's got to say on this subject. One of the ways that we think this is going to needs to be tackled is basically citing sources, good old-fashioned information technique. So we've worked with a partner, Squirrow, who hit on the idea of, for everything that an LLM comes back with, cite the source, explain where you got that decision from. That's just one sort of way of tackling this. But ultimately, there really is a lot of promise in that generative AI world, and a lot of opportunity for us as taxonomists to make what they do a lot better. So with that, let me segue to introduce your first speaker for today. Fran Alexander is going to talk about LLMs versus knowledge graphs, alien v predator. So this is going to look like a very fun presentation. Fran started her career as a writer and editor of dictionaries and thesauri in the UK. And as technology evolved, she specialized in information architecture, search systems, digital archives, and more recently, knowledge graphs. I actually first met Fran, we were talking about 15 years ago when she was on a digital archive project at the BBC. Fran now lives in Montreal, Canada, and is the taxonomist for the Expedia Group. And Fran also won the Bite Size Taxonomy Bootcamp Taxonomist of the Year Award last year in 2023. Over to you, Fran.
Thank you, Dave, and thank for that lovely introduction. And thank you, Helen. I am going to share my screen. Let's see if this is working. So thank you very much. I am here as a private citizen, so everything I say in this is my own personal opinion, not necessarily that of my employer. And just a little note, copyright in Alien versus Predator is owned by the Disney Corporation. So Alien versus Predator. For anyone who doesn't know Alien and Predator, there's just a little bit of an introduction. Why did I choose Alien versus Predator as a way of talking about LLMs and knowledge graphs? Well, they can seem, from a taxonomist point of view, very big, scary alien technologies. The Alien film actually came out in 1979, so quite a long time ago, and the Predator film, the first Predator film was in 1987. So these are sci-fi monsters. The Alien versus Predator franchise the films was released in 2004 based on graphic novels from before then. And independently, the Alien franchise, the Predator franchise, and the Alien versus Predator franchise have both been very successful, particularly with lots of video games. So before we get going, very important question. Why did I choose Alien versus Predator and not Godzilla versus King Kong? And the answer to that is, well, Godzilla versus King Kong would probably work. And, you know, I would encourage you to think about Godzilla versus King Kong and whether those analogies would work for knowledge graphs and LLMs as well. Probably could. I also wondered about Star Trek and whether I could use the Borg in some way. But Alien versus Predator seemed to work particularly well, and I will explain why. So, characteristics of aliens versus characteristics of predators. Well, aliens, they're not like humans at all. They have acid for blood. They're completely different physiologically to humans. Whereas predators, they're a bit more humanoid. They look a bit more like us. Aliens, no obvious social hierarchies, some family relationships. There's a bit in Alien Resurrection about sort of motherhood and eggs and so on. But basically, aliens just kill everything and make more aliens. Whereas predators come from there's a predator society. They have social hierarchies, they have social relationships, they have lead predators and so on. Aliens don't have any obvious morality, at least not obvious to us from a human perspective, whereas predators have morality in their society. They have their own predator right and wrong ways of behaving. Very hard to understand motivations and intentions of aliens. Very, very strange and weird. So we don't know what they do other than kind of go around laying alien eggs and killing things. Predators have quite clear motivations and intentions. They're mercenaries, basically. We know what they want to do. They're out to make money and kill things and do what they're supposed to do as predators. Aliens just kind of kill everything that isn't an alien, eat everything that isn't an alien. Predators select specific targets, so that's quite focused and controlled in what they do. Alien, extremely powerful. Predator, also extremely powerful. So how do these relate to LLMs and knowledge graphs? Why do I think this is a good analogy? So aliens, not like humans. So LLMs, not like humans. They don't have acid for blood, but they're statistics-based learning. And I've said maths for blood. They don't really kind of work in the same way as humans, certainly how we like to think of ourselves. They're very mathematical. That's a very different take on the world. What do they do? How do they process the world? Well, you put an input into an LLM, and this is very high level. I'm not an expert in Gen AI engineering, but basically this is how I like to think of it, and people can correct me and refine this. But you put a load of input into your LLM, text, images, audio, and whatever. It chops it up into lots of little pieces, identifies all the pieces and works out which ones are similar to each other. And then it calculates the probabilities of those pieces occurring together or in sequences. And then all the clever stuff happens. All the layers of algorithms and machine learning are basically refining those probability calculations. And then they use those probability calculations to match an input, like the question that you type in, to a likely output answer. So you put a sentence in, it does all its probability stuff. That's all happening behind the scenes. And then it generates the most probable sequence of words if it's text, or draws a picture, puts pixels in the most probable order, and refines with more machine learning. So that's really that's not how humans tend to go about working with the world. No obvious hierarchies. Well, any hierarchical structures that LLMs use are detected based on the probability calculations from the input data. So they can change. The garbage in, garbage out problem happens. Different inputs will generate different results. So there can be a lack of stability and explainability. You can ask the same question and get different answers, basically. And so there's potential for gaps in logic. You're very dependent on the training data, the training models, the training algorithms, and so on. so there's potential for misleading structures and mismatches with human understanding of hierarchies as well. Because it's not how we tend to create and think of hierarchies isn't just based on probabilities. It's based on the way we think conceptually. No obvious morality. Bias in, bias out. There's been a lot of attention in the press with bias. One of the problems with bias and LLMs is that in order to get good, eloquent results, you need to put a lot of data in. And so a lot of LLMs have been trained on all the data that's out there in the web, on the web. And the problem with all the data that's out there on the web is there's a lot of biased rubbish out there. So that's gone into the training model. We know that generally, there's bias towards kind of North America and so on, and bias towards wealthier white male viewpoints and so on. So that's all gone into the training data, and it's gone in a way that's very hard to unpick. So again, the probabilities from the data set, they're just probabilities. There's no kind of, way. It's quite hard to unpick the biases that have gone in with the data. And this is where we're seeing problems with hallucinations, deep fake images. So you need verification, as Dave mentioned. Just the pure probabilities can bring results that are not true, basically. The results are very eloquent. And this is quite dangerous because as human beings, we trust eloquence more than we trust factualness. We fall for the silver-tongued smooth talker. We really do. So there's a big potential for LLMs to be kind of, scam artists on steroids. We love the way that they frame the results, but we're more likely to go, oh yes, that sounds confident, that's beautifully phrased, it must be true. There's studies done. I put a link in the references to studies that actually show, as humans, we fall for that. People will actually distrust facts that are presented in a less eloquent, less elegant way, and they will believe fancy sentences that are just not true. So there have been incidences of LLMs telling people to commit crimes and doing all sorts of things. So you need some guardrails around that. And there's even problems when people start to become emotionally involved with LLMs and chatbots. There have been cases of people having sort of virtual girlfriends and then being devastated when those get shut down kind of randomly. So that's an interesting aspect to think about. Very hard to understand their motivations and intentions. Just like aliens, we have no idea what goes on inside the mind, as it were. And this is to do with the complex layers of machine learning and neural networks and the algorithms. Those are very, very hard to explain, and the calculations are just too big and complex for us to follow now. And self-adjusting models and weights mean lack of traceability. So the black box and opacity, as Dave mentioned, that can happen in auto-categorization. Whenever you're using lots and lots of complexity, it gets harder and harder to explain. So really the problem with LLMs is, we can't unpick. It's so hard to unpick all those inputs. I like to think of like thousands and thousands of Excel spreadsheets with thousands and thousands of formulas all connected together, and you change one tiny little thing and then the ripple effect that goes through the results. It's almost impossible then to unpick that and go, oh yeah, we tweaked this one bit here in this one place, and that has somehow had a ripple to something else, some other data point somewhere else. And because these things are so huge, they're very hard for us to understand. The danger in that is that we can get the kind of the computer says no phenomenon. You put an input in, you get a result out. Why? Why did you get that result out? Well, something somewhere in the model and the probabilities has come up with that as the result, but it's very hard to say why. And this again is problematic with bias. In situations like there've been examples, people applying for jobs where you've got kind of Gen AI and sophisticated ML techniques sorting out CVs. What is it that's causing that CV to be rejected? What is it that's causing that grant not to be awarded? There've been cases with like social security payments and benefits and so on that you just say, you know, should this person get this benefit? And the result comes out no. Very, very hard to say why. You know, is it your postcode? Is it the school you went to? Is it your name? And very difficult then for people to turn around and go, I think this is wrong. The computer should not have rejected. I should not have been rejected, but computer says no. And everyone just kind of shrugs their shoulders and goes, well, what can we do? So that's something to think about. How do we have mechanisms for challenging the outputs? And then stale data, that's another thing, because LLMs take a long time to train and a lot of data. It's quite hard to keep them topped up with fresh new data. So that can be an issue as well. They can just be sort of slightly out of date. Kills everything in their path. Well, I'm not suggesting that LLMs like aliens are just kind of killing everything, but I've taken this as a bit of a metaphor for corporate attention and investment. So this is something that's been happening over the last couple of years. You know, everyone's eyes have lit up at LLMs, and people have wanted to put lots and lots of money. So consumes all investment rather than kind of killing everything, consuming all corporate attention. But LLMs are now getting to the top of the Gartner hype cycle, and they're about to tip over the peak of inflated expectations and start moving down into the trough of disillusionment, which is interesting for us. I found people have actually started coming to me now saying, my LLM isn't doing everything I hoped it would. Can you help with some structured data? So that's really nice and positive. So they can be expensive. Query processing times can actually be quite slow. I put some figures in there. It can actually take quite a long time to query an LLM compared with querying, say, Wikidata. So external data sets may not be appropriate for your corporate use case, your internal use case, your very specialized use case, but building and training your own LLM can be expensive and time consuming. They are extremely powerful, just like aliens. They work on unprecedented scale, extremely eloquent, extremely convincing. People love interacting with natural language, and that's important. That's something that is trickier for kind of simpler query systems like Wikidata. People love those natural language inputs. And there's lots and lots of interesting applications in code development, creative prompting, text analysis, and even taxonomy, ontology, and development as well. So why are knowledge graphs like predators? Well, a bit more humanoid. So knowledge graphs, they're built on conceptual worldviews, they're modeled from human user perspectives, structures based on user perspectives, often very heavily rooted in subject matter and domain expert knowledge. So there's that they're not just based on maths and probability, they're based on the way that we think about our subjects and our domains. Complex hierarchies and structures, our ontologies and taxonomies that we know and love, our structured data, our clearly identified concepts, and our data organized into familiar or functional domains. So it's not just a huge sort of mass of everything getting mixed up together. It's very, very specific domains and functions underpinning the knowledge graphs, which helps with explainability and so on. So complex, well-ordered societies, as predator society has its rules and regulations, and knowledge graphs, we have inferencing based on logical rules, concepts linked according to meaning and function. We don't get away. We still have the garbage in, garbage out problem. We still have bias problems with knowledge graphs, particularly when you're using lots of data and bringing in lots of data at scale. But those biases in knowledge graphs tend to be more explicit. It's easier to validate your data, and it's easier to go and pinpoint invalid data and remove it. So, and this is linked to the fact that, you know, you're often working within a domain, and it's quite explicit. The biases within that domain are going to be around the subject matter and the function. So yes, you can still fill up your knowledge graph with biased nonsense and rubbish, but then it's probably easier to fix that when you identify those problems. Epistemological foundations, I just throw this in there. It's a good argument for knowledge graphs, you can have lots of authority, tracing of sources, lineage of sources, confidence weighting for the authoritativeness of sources. And a sound epistemological foundation for objectivity is to have lots and lots of different voices, so you can have a consensus. And that actually, you know, is an interesting thing. How do you do that with LLMs? And can you use knowledge graphs to give a sounder epistemological basis to the information in your LLM? Can you allow all those different voices to come together and have an objective consensus? Clear intentions. So like predators, we know what the knowledge graph is going to do. It's built for a purpose. It's clear what it's intended to do. It's clear about what data's gone in there, what sort of questions can be answered. And this helps with the explainability. Inferencing rules are there. They're transparent. You can trace back how the concepts are linked together, why a set of logical rules has generated a particular output. Connections are very explicit, so that means it's easier for us to kind of trace the results that we get. Select specific targets. The predator's out to target one particular mission. And knowledge graphs tend to be built to answer very specific questions within specific domains. That's something you can do with LLMs, but a lot of the large general ones don't tend to do that. They want to be very generalized, and they work better at a very generalized scale. All that eloquence comes in because they're so generalized. But that creates the problems of the lack of specificity. Whereas with knowledge graphs, we tend to know what the function and purpose is. We build inferencing rules. We set up our ontologies with specific data and specific questions in mind. So we know what the knowledge graph is intended to do. We know what the data is for. We know the sort of questions it can answer. We understand the scope. And that helps us with validation and veracity and so on. And knowledge graphs are also extremely powerful. Do lots of big data processing, operate at web scale. The reliability of the rules and the processing is important, and the speed can be in there. There's lots and lots of techniques out there to improve speed and power, and embeddings can be used with knowledge graphs, lots of indexing techniques to help query processing time, and they can be faster and cheaper to run than LLMs. So this is a little experiment that I did. This is one I've thrown in. I mentioned this to Dave. I asked the GitHub Copilot Gen AI LM based system, what's the best taxonomy management system? And it came back and said Synaptica, taxonomy and ontology management software. So and talked about graphite, and that was nice. So Dave will be very pleased about that. But then, this is the problem with LLMs. It went on to say that graphite is part of the top braid suite. So sorry, Dave. Copilot thinks that graphite is part of top braid, made by Top Quadrant. And it then went on to tell me that Top Quadrant offers pool party semantic suite. So the semantic web company won't be happy about that. I don't know how Copilot has come up with saying that Top Quadrant is now building not only top braid, but also graphite by Synaptica and pool party. But this is a really good, and it all sounds beautiful. It's elegant. It seems completely plausible. I know it's wrong because I know my taxonomy management software systems and vendors. But there's nothing in this really that would leap out to someone who didn't know the domain to say that this is not true. It all sounds completely plausible. So this is a really good illustration of the dangers, potential dangers with generative AI. I mean, you can imagine this could be in all sorts of like problematic situations if someone's trusting the results too much and doesn't know the subject matter. Lots of business use cases where you could get into a lot of trouble for giving misleading information. So don't have much time. I'd love to go into more detail about this, but where people are looking at now, this is a bit of a model, is using LLMs and knowledge graphs together. So you can use your knowledge graph alongside your LLM. You can convert your queries and you can convert your outputs, validate them against data in your knowledge graph. You can put your guardrails up and say to the LLM, only use facts that come out of this knowledge graph. You can also use the knowledge graphs to top up your LLM with more up-to-date data, because it's faster and quicker to put fresh data into your knowledge graph. So this way you can use your knowledge graph as the kind of fact checker to make sure the output coming out of the LLM is true, and you can limit the LLM to only use the data that's within the knowledge graph. And so this is it's a kind of a model of describing the knowledge graph working alongside the LLM as a kind of working memory graph. Memory over time is another interesting aspect. LLMs tend to be just in the moment. They're people are working on like more memory within conversation memory features for LLMs now, but knowledge graphs are still better at storing data over time. So this is one model of using a knowledge graph as the kind of memory and archive to sit next to an LLM. Here's another one, a fact-checking model using an LLM alongside Wikidata and using Wikidata as the fact checker. And this is nice because then you can use your LLM for your lovely natural language input and output and give people beautiful paragraphs, but you've got the solid facts sitting behind it to make sure that it's not giving misleading information. So there's lots of kind of architectures people are working on these kind of combined models now. So just to kind of sum up, here are some things where LLMs and knowledge graphs can complement each other. So problems with LLMs are the hallucinations, the expense, stale data, and the opacity. Whereas knowledge graphs can be factual, cheaper, easier to update, and more transparent. So LLMs are good for user-facing conversations, whereas knowledge graphs are good for looking up facts. LLMs are good at complex natural language queries and eloquent outputs, whereas in knowledge graphs, simpler outputs, but we've got that nice, clear, logical inferencing, historical snapshots, and storage of data over time, building up that archive to go, what was the state of data? So we can go back and do trend analysis and so on. So your LLM use cases are good around chatting, friendly interfaces, entertaining, and knowledge graphs are stronger at the moment for kind of recommendations, trends, and analysis. A whole other topic that I would love to go into, a whole topic for another session, is actually how as taxonomists can we use LLMs to help us build taxonomies and ontologies. Heather Hedden has written a nice blog post about that with lots of ideas, so I've linked to that there because it is fun. We've done some experiments of saying, you know, suggest to me the important concepts in this domain, suggest to me an ontology, and even generating code, even generating RDF and OWL using LLMs is interesting. But you do have to watch out for the lack of truthfulness. So to sum up, we shouldn't be terrified of alien LLMs or terrified of huge predator-like knowledge graphs. Actually, the way to go forward and be positive and to get us out of the trough of disillusionment and moving up the hype cycle onto the plateau of productivity is to get them working together. They can be friends. I really believe this is the way that's going to lead us to success. Harnessing the power, the strange and remarkable power of those alien LLMs with our kind of slightly more familiar and conceptual and logical, transparent and well-targeted predators, and get the best of both worlds, find the appropriate use cases for either, and make them work for us. So that's all from me. Thank you very much.
Excellent. Thank you, Fran. Big round of applause, and on the screen as well. Questions. If you've got a question, ideally please post it. If you go to the bottom of the Zoom, there's a Q&A button, and you can post a question in there. Ideally, there was a question in there which I think you already answered, which was about eloquence and truthfulness and where that comes from. And I think you said you've got a citation for that. There's another question just, there's a question in about where to read the blog post that Fran mentioned, Heather Hedden's. That's going to be in the slides, isn't it, Helen? Sorry.
Yeah.
Yeah.
So I put I've put some references here, some links to interesting articles that that you can go and look up for more detail. So I've got, so Heather Hedden's post is here, taxonomies and chat GPT. People often trust eloquence more than honesty. In there, I also included what chat GPT says about taxonomies and ontologies, because that's kind of fun. So there's some further reading in the slides.
Yeah. Well, post any questions if you've got more questions. Shannon Moore, one of the panelists, made a good comment in chat, which was people are using large language models as if they're a big knowledge base, as if they're a fact base, and that's actually an error of judgment in terms of what they are. They're really just this big pea soup of words that are used to help process inbound for machine understanding and machine generation, but it's not that it was ever sort of this curated source of knowledge. So I think that was a really well made point you put, Shannon, in the chat. But I loved really, Fran, how you kind of drew everything together in terms of the pros and cons, relative virtues of knowledge graphs and LLMs, and do think that, you know, there is going to be some really good synergy. So, you know, for the taxonomy community, I think LLMs have been a challenge in terms of grabbing the budget, corporate budget, but they're also a bigger opportunity if we can tame them. Any more questions? We've got a few minutes, I think. There's a question, Shannon, that's posted in the chat window, if you could have a look.
Let's see. I stop here. Okay,
yeah. So the question, oh, actually, the question is from Joshua to Shannon. What do you think about LLMs which are good about citation, like Perplexity, for example? So LLMs that cite sources, do you have any, or does anyone else have any comment on that?
And I know there have been cases of LLMs inventing citations. So this is a hallucination problem. It's come up with, you know, LLMs creating fake academic papers. And that's something to think about because of the probability, you know, when you think about probabilities, the LLM probability can go, okay, this is some text. And when we have this kind of text, there's a high probability that there'll be a citation. And there's a high probability that a citation will have the name of this author, because this author tends to write a lot of papers. And there's a high probability that the citation, the form of an academic paper's name, will have these kind of words in. So the LLM then generates, you know, understanding LLM capabilities with epistemology and citation truthfulness, 2009 by Fran Alexander and Dave Clark, page 51, chapter 1, page 52 of the Journal of LLMs and Truthfulness. And that might be what happens to win the probability calculations. And it sounds like a beautiful academic paper and a citation, but it just doesn't exist. So that can be a problem with citations. There's been a case of a lawyer in court that came up in the States. A lawyer had a generated law case precedent used in court, and somebody said this isn't true, that didn't happen, and that was a subject matter expert who recognized that that wasn't a genuine citation. It came out of generative AI because it sounded like the sort of thing that you would say. So yes, so that's a big problem. I mean, that was exactly the, you know, top quadrant make pool party example. It sounds plausible. It could be plausible. It doesn't seem wrong, but it's just not true.
Yeah. We've got a question in chat. Fran. So do you have a view on the use of RAG, which is retrieval augmented
Yeah.
generation, and how structured data might assist that? And there's also a new question in Q&A, but if you want to tackle the chat one first.
Yeah, so retrieval augmented generation is exactly what people are doing to try and solve the hallucination problem. How do we put some fact checking in there? How do we do put some validation and correction to make sure that we get the best of both. We get the lovely eloquence, but we put some guardrails and protections around that. And looking at these kind of hybrid models, I think is going to be the way forward. And it's actually a really exciting time for us in structured data, because all the excitement over the LLMs, it only takes a few cases in business for some nonsense answers to be put out there and cause a problem, and they're coming to us and saying, actually, this is a problem. How can techniques like retrieval augmented generation help us solve this? So yeah, I think that direction. I'm not an expert in any of that, but I can see that's where a lot of work is going, and those kind of architectures, I think, are a good way forward.
Very good.
Am I able, Dave, just to step in? This is Emerson from Quark here. Cool. I just wanted to add some context to that. So we provide enterprise content lifecycle management software, but we provide it to very highly regulated industries. So the companies that are in financial services or life sciences, for example. And what they're doing is they're connecting their own AI services and LLMs. So they're not actually using any outward information coming in. So that's a trend that we're seeing, is everybody's actually using their own protected data that they can trust, that they know is structured, that they're retrieving from very reputable sources, i.e. their own databases, which have been through a very heavy review cycle. And they therefore know that it's been approved, because they're worried about things like every time you search, you get a different result. So just adding a bit of context to what you were just saying, Fran, that's exactly what we're seeing in the market space that we're in. People are actually connecting their own LLMs and building their own data and not taking any risks external from that.
Yeah. Oh, and Heather, I see Heather's put a link there. A newer blog article, generative AI for taxonomy creation, which will be published on April the 3rd, Enterprise Knowledge. So look out for that. I should look out for that. Thank you, Heather. Always enjoy your articles, very helpful.
Yeah, some more comments in chat about Shannon using Gen AI to produce candidate terms for developing local taxonomies. And that, I think that is a whole topic for maybe another boot camp session, is the generative contribution to taxonomy and structure. And we've certainly been doing experiments with using LLMs for not just novel entity extraction, but for fact extraction. And there are some promising opportunities there. Q&A questions. Helen, any views on the commercial perspective about misinformation generated by LLMs? I don't really have an answer on that one, Helen, other than it's going to be an issue, and it's also going to be an issue in terms of copyright. I think I heard that there are authors sort of suing big sort of GPT type generators for basically plagiarizing their works and synthesizing them, because AI is being used, from everything from writing content to writing scripts for plays and films and so forth, and yet it is basically regurgitating a lot of stuff that it's read. So commercially, yeah, I think no answers other than it's going to be a bit of a Wild West for a while. There is another question from Victoria in Q&A, thanking you, Emerson. And even if you use your own data, can LLMs hallucinate with that kind of internal content. Do you have a comment on that?
I think it's yet to be seen by a lot of them. I think that's why they're so sort of focused around and trying to make sure they use trusted data. I think, Dave, you're probably even better to answer that question than me, but I think it's that cautious approach. They know that they've got to be using AI. They can see the benefits, but it's just those risks when it comes to things like fines, human health, accidents, claims, and things like that in those regulated industries. So it's more about, I think, just eliminating those hallucinations or just minimizing them as much as possible. I think it's yet to be seen. But just to give you an idea, one of our customers is a big bank, and they've actually got a team now within the bank who are just going around all of the departments within this massive bank, just identifying areas where they can apply AI and where they can use LLMs to actually help generate better service and increase revenues and things like that. So it's actively happening, but we are still really in very young stages.
There is still a risk, even with internal data, that the LLMs will generate outputs that are not correct. If you've got a lot of answers within your internal data that skew one way as opposed to another. So there have been, there've been examples with virtual assistants just giving incorrect information about, like, how do I get this product replaced, or what do I do if I want to change my flight, and the answer will come back, oh, you need to call this number. Well, that's the number that you'd normally call, or that comes up a lot for customer service, but isn't actually the number that particular person needs to call, because in that case they need to call their airline. So
Right.
even though it's based on information that's true, it's giving the most probable answer, which is not necessarily the answer that's needed in that particular context. So there's lots of risks. There's going to be a lot of work in de-risking and sorting all this out, for sure.
Yeah, there was an amusing one I think I read in the news very recently about a virtual assistant in travel that misquoted an airline price significantly under what it was supposed to have answered. And it went to court, and the court said, you've got to honor that price. It may be a robot, but the robot works for you. So, it's a Wild West. But I mean, one of the things we do with some of our clients is we build what I would call a process-oriented taxonomy. So most taxonomies are built for information retrieval, and the structures are, classification-based. Some of our clients build what we call this process-orientated, and they basically say, if you've got this customer reaction, then the next thing is this, or this is the dependency that you need to draw on. So the graph is kind of mapping out all of the logical processes that a business goes through. And actually that, I think, built in with, these LLMs greatly improve the virtual assistant's ability to communicate and understand, but they need graphs. This is, I mean, you've already talked about it, Fran, but they need the graph for the process model. And I think, this is another area where the taxonomy community can really help with that. Helen, I'm not sure how we're doing for time, whether there's a hard stop.
Yeah, we are a little bit over. So for questions, for things that are still in the Q&A, if Fran is happy, we can get an answer to that later and send it out to people. Just because I'm aware we need a comfort break. Are you okay with that, Fran?
Yeah, certainly.
Yeah, no, sorry we didn't get to everyone. It often happens that way, that the discussion just snowballs. But yeah, we'll look at everything that's been put in and send it on to people.
Great.
But yeah, we're back. Sorry, Dave.
Yeah, I was just thanks, Fran, and we'll shut this session down then.
Oh, thank you.
Thanks, Dave.
Thanks,
See
everybody.
everyone at the top of the hour.